Hello everyone, welcome to the Global Mapper webinar for the month of January. My name is Josie McKnight. I'm an applications specialist here at Blue Marble Geographics, and with me today is David McKittrick.
Hi Josie, and hi everyone, and thanks for joining us today for our latest in our Global Mapper webinar series. Those of you who attended last month's webinar may remember that we talked about LiDAR data. We talked about working with LiDAR data in Global Mapper. And we promised that we would continue on the same basic theme, and that is the case today. We're going to be taking those LiDAR files, or basically the end product of those LiDAR files, those terrain models that we generated. I'm going to talk about some of the terrain capability, the terrain functionality within Global Mapper today. So that is the plan of attack. Hopefully you can stay with us for the next hour, and we'll cover all of the terrain functionality that we have available in the application.
Great. This session is being recorded and we'll have it available on our Blue Marble website within a few days. So before we begin, there are a few housekeeping issues to cover. All webinar attendees are in listen-only mode. So in other words, you can hear us, but we can't hear you. If you want to submit a question about today's topic, you can use the questions tool on the GoToWebinar panel to the right of your screen. Blue Marble product specialists will try to answer your questions in written form as they're submitted, and we'll also try to answer some verbally as time permits.
And as we always remind you, the email address at the bottom is always available to you. If we don't have a chance to answer your questions today, and it's quite likely that that will be the case, we have a very heavy attendance today, and if we don't have a chance to get to your question, please follow up with us through the geohelp@bluemarblegeo.com email. Or you can try the forum. I'll give you that information towards the end of our session.
Okay, upcoming events in January will be at the SOLIC Symposium and Exhibition in Washington, D.C. January 29th will be at the Maine Society of Land Surveyors annual meeting in Rockland, Maine. February 2nd will be at the Maine GIS Users Group meeting in Portland, Maine. And then February 23rd will be at the International LiDAR Mapping Forum in Denver, Colorado. So a few dates close to home for us.
Yeah, and you'll see the website at the bottom of that slide. If you want some more information, links to those events, you can go to that website. We've obviously limited our events to the next couple of months. We have a lot of additional travel plans coming up in March and into April. So hopefully we'll be in your part of the world sometime soon, and if we are, we look forward to having an opportunity to meet with you. Let's take a look at what the plan is for today. And again, we went through our agenda. Josie and I sat down and planned out what we were going to do, and we quickly realized that we have a lot of content to cover. So by way of disclaimer, we may go through some of these functions fairly quickly, and we want to make sure we have time to cover everything that we want to cover. So we may not stop on every dialog box and every configuration dialog box, but hopefully you'll get an idea as to some of the terrain capability within the application. First thing we're going to address is how do we get terrain data? How do we get our hands on it? How do you start? Again, those of you who had a chance to sit in on last month's webinar will be aware of the fact that LiDAR is a primary source of terrain data. I'm not going to spend a lot of time going through that functionality again. If you want some more information on that, the webinar has been recorded. It is available on our website. But we'll talk a little bit about some of the alternative methods for accessing terrain data. We'll talk about creating terrain, transforming, I should say, perhaps a point cloud or some vector point data into a terrain model. We'll go through that gridding process in Global Mapper. One of the primary functions that people use terrain data for within Global Mapper is contour generation. Very simple procedure, very straightforward procedure. We'll show you that very quickly and how you can generate custom contours within the application. We'll get into some of the analysis functions as well. We want to talk about line of sight analysis. It's a kind of a byproduct of our path profile tool. We'll introduce that one to you. We'll talk about viewshed analysis, the ability to determine visibility from a location, or for more than one location. The scenario will actually show you has multiple locations, and we'll show what's visible or what can be seen from those multiple locations. I'll give you an interesting application of that a little bit later in our presentation. Josie's going to introduce a lot of the volume calculation capability, multiple ways of determining volume, of being able to calculate volume, measure volume, or even model those calculations in a three-dimensional form as well. We'll introduce those. Terrain flattening, this is basically our cut and fill analysis function that we've really done a lot of work in the last few releases of Global Mapper. Generating a flattened surface, a byproduct of that is obviously volume calculation as well, but it'll also allow us to generate a modified terrain surface. So we'll go through a little scenario as far as terrain flattening is concerned. Gosh, the list goes on and on. Watershed modeling is another one that we want to introduce, the ability to basically do a hydrological modeling scenario. And we've got a couple of very simple examples. We'll do a water drop analysis. We'll also generate a catchment area or a watershed for a defined location. And the final one, I'm hoping we have time for this one at the end of our session today. Instead of looking specifically at elevation, we're going to take a little bit of time and look at slope and do a slope analysis procedure as well. So as you can see, a lot to cover. We will hopefully not go too fast that we lose you, but we want to make sure we can cover as many of these bullets as we can in the time available. So I'm going to switch back to the application itself and hand over to Josie. She's going to talk a little bit about, actually no, I'll start. Why don't we talk a little bit about accessing terrain? This is going to be very fast. I mentioned last month we have LiDAR as a source of data for working with terrain data. That is not the only source. If you go to the standard open data file dialog box in Global Mapper, you will notice that there is a dedicated filter for elevation types, and there are many. .dem files are supported. .dted is another format. So there are multiple formats that you can access. Very often these files could be downloaded, and maybe websites available that will provide access to these data sets. So you can filter your import by elevation data. I'm not going to go any further with that. We'll actually be working with some pre-configured files in just a minute. So access to data in a file format is certainly an option in Global Mapper. I'm going to cancel this. We're going to go ahead and show you another function. The other way of getting data is through one of our online sources. I'm going to bring up the online data source dialog box. Those of you who are familiar with Global Mapper will be very familiar with this tool. It's something that we really promote a lot within the application, the ability to access data from online sources. And this list, by the way, has been increasing. The data types and the volume of data has really been increasing. You will notice on this online data source dialog box, there is a dedicated terrain data list. And under terrain data, you'll notice a number of sources of data that are available, often free of charge. Sometimes you may have to have a subscription to that provider. For instance, our partners at Intermap will provide data if you have a subscription to their service. Some of the free sources here in the US, you can get 10-meter resolution national elevation data at no cost, streamed online, and available for the entire US. 30-meter or 10-meter resolution data sets are available from that source. Those of you outside of the US, we have a number of sources as well. We have the Aster Global Digital Elevation Model. With the release of version 16, we introduced a higher resolution version of this, 1 arc-second resolution, about 30-meter resolution, worldwide coverage for that one. And again, that's available to you at no cost. So if you don't have access to high-resolution data, if you don't have access to some of the premium data sets, there's certainly a lot of readily available, inexpensive or free data sets available as well. So we're going to be working with some of the data from these sources that I captured and saved locally on my machine. But we could, as a starting point for working with terrain data, stream our data using these web map services. So Josie, now.
Okay, well let's look at creating or getting a terrain surface in a different way, a terrain grid. We're going to start with a point layer, so I'm going to import an ASCII text file. I'll just bring it in here from our recent. You can see the import option dialog comes up. These are points only, so I'm just going to choose that option and click OK. I'm also just going to go with this projection because it's not as important today to be so specific here. And as you can see here, we've got points, and they're in a grid. I'm just going to click on one and show you they each have an elevation value. And to turn this set of points into a terrain grid, I'm just going to go Analysis and Create Elevation Grid from 3D Vector Data. So I'm going to click on that. Here's our options dialog. I'm not going to go through this step by step. I'm going to go with all the default options here, but Just keep in mind if you're working with LiDAR data, you'll have another option here to choose a different gridding method if you have LiDAR and you have the LiDAR module. So so that might be something that's changed if you're depending on the data you have. And this is an extremely powerful tool for LiDAR data. Just you might want to refer to last month's webinar to learn more about that. Okay, I'm going to click OK. And as you can see, I've created this terrain grid. I'm going to turn off our points layer. And here's the grid. You can see the elevation legend shows up on the left-hand side. And we're currently in the Atlas shader, so the highest points are red and the lowest points are blue.
And it should be stressed that we didn't have a chance to address the source file, but it was a very simple file. It was simply a tabular data set. In this case, it was a simple common delimited data set with an X value, Y value, and then the final column was a Z or a Z value, in other words, an elevation. So it doesn't have to be overly complex. Josie was able to create a very, very nice terrain model from simple XYZ point data.
Great, thanks, David.
And I mean, another source, as we mentioned, is LiDAR. Same procedure. If you've got a point cloud, the method for transforming a point cloud into something such as you see on the screen right now is the same process. It's a standard gridding process, generating an interpolated elevation model from an array of points. I've often suggested, if some of you have been to my training classes, you may have heard me suggest this as a kind of a crude way of generating a terrain model. You could quite literally walk around an area with a GPS receiver collecting waypoints. If your GPS receiver includes the ability to collect terrain as well, the array of points that you create could essentially be used to generate a surface model such as you see here. Obviously the accuracy of the Z value will be dependent on the accuracy of your GPS receiver. The example that Josie showed us was a fairly regular array of points, but it doesn't have to be. It can be a randomly arrayed point layer that can be used to generate this surface. So, excellent.
David, do you want to take us through some other terrain configuration and visualization
Sure. I mean,
options?
now that we have terrain in place, we're going to take some time and look at some of the visualization options. Apologies, I removed your artwork there, Josie. We'll bring in a pre-configured file. This is actually a LiDAR-derived terrain model. Taking a little more time to load here. This is essentially the same as what Josie showed us from a point layer, but this point layer was obviously much higher resolution, and the result is a much higher terrain model. As you can see, again, as Josie mentioned, upland areas in this case are red color, lowland areas are blue colors. Now, this particular visualization of terrain is what we refer to as our Atlas shader. The Atlas shader generates an array of colors going from blue through red, through greens, yellows, and oranges. This color range is dictated by the range of values within your layer. In my case, my elevation ranges from about 42 meters to just over 110 meters, and that's the range of colors that's on the map. There is a configuration option in the configuration dialog box that will allow me to adjust those ranges based on what's on my screen. Some of you may not have seen this. It's a fairly new addition to the configuration dialog box. But if I zoomed into a particular area and I still wanted to display this color range for that localized area, just make sure that checkbox is checked and you will get that effect applied. Now, the Atlas shader is by no means the only visualization options. This is kind of an interesting application because we're dealing with raster data here. What Josie generated, what I have on the screen, is a raster layer. But it's a raster layer with a difference. In other words, it's not a raster layer where the visualization is dictated by the inherent RGB value in each pixel, but rather the visualization is dictated by the Z value. And exploiting that Z value or utilizing that Z value, we can change the visual characteristics. And I'll give you a couple of examples. I'm going to choose a gradient shader. Now, I'm not changing the data, but what's going to happen is it's going to change the visual representation of that layer. In this case, again, looking at my elevation legend on the left side, it's going from black to white, black being the lowest elevations, white being the highest elevations. There are many others. slope shader, we're going to bring that one up a little bit later. There's a global shader in which the colors are applied universally across the globe. Every area will have the same colors. Great if you're working with data from multiple locations and you want to do a visual comparison of elevation that's consistent. Global shader is what you'll choose there. So again, multiple options available for visualization of your terrain. You will notice at the bottom of this menu there's also a custom shader option. We're not going to go there today, but you can apply whatever color pattern you want based on whatever elevation thresholds you want, and basically apply that to any imported or any generated elevation layer. So multiple shader options. It wouldn't be a 3D or a terrain webinar if we did not early in our webinar introduce the 3D window. The little button in the toolbar I clicked adjacent to my shader drop down brings up the 3D window. Some of the recent changes, you'll notice the color in the distance. We have I think a more appropriate visual context for any terrain there. We actually put something realistic in the background. Today is a tropical sunny day, certainly not here in Maine in January, but I'm sure somewhere it is. We can change that. We have different options as far as the background is concerned. The terrain, as you'll notice, I'm moving around on the terrain simply by moving my cursor. It focuses on a particular point and allows me to adjust the perspective at that point, both in terms of pitch and in terms of rotational angle. Excuse me for my my shaking cursor here, but we can change that view. We can change the exaggeration. If your terrain is relatively flat and you want to accentuate the elevation changes, there's a toggle in the toolbar that lets me emphasize the height or decrease that if necessary. So two options in there for essentially creating mountains out of molehills, as they say. You can also change your perspective of the terrain from simply a top-down look to what we call a walk mode look. Now, walk mode allows me, it seems a little high right now, I'm actually 102 meters off the ground. I want to change that. Let's bring walk mode down to, let's say, 5 meters. And you'll see that I'm actually on the terrain now. I'm actually walking through the terrain. And my cursor, I'm clicking with my cursor and essentially walking over the terrain. As I move my cursor left and right, it goes left and right, or forward, it will take me at that height above the ground across the terrain. So just a different way of visualizing the terrain. I find that one to be very useful for a more realistic perspective. You're not looking at the terrain from a remote perspective, but you're right on the ground or at whatever elevation you decide. Another thing I want to show you in this dialog, this 3D dialog box, which is very interesting, is the ability to render water. Now, the option to enable that is available both as a toolbar option. I'm just hovering my cursor over the buttons in the toolbar, but you can also enable it here in the configuration dialog box. I'm going to check that box now, and I'm going to specify through the slider bar my water level. And those of you who are looking at the screen can see perhaps the water encroaching as I move that slider along. So you can simulate what a flooding event would look like by simply dragging this back and forth, as you can see. And this is just a visual representation based on a specified water level value, which in my case is 99 meters, what that would look like. Very useful for coastal applications if you want to simulate or visualize what inundation of sea level rise would look like on the terrain. Very quick, very easy way to visualize that using this. And you can see the water level is a semi-transparent color. So just another visualization option. I'll turn off my water for the time being. And let's go ahead and click OK. I'm going to go back into the standard dialog box. I think I have another layer loaded. I do. I have an imagery layer. So I'm going to turn on the imagery layer. Now, these are two raster layers that we have displayed right now. Essentially, I have an ortho image now sitting on top of that underlying terrain. Because these are raster, you obviously can only see one at a time. So I'm going to introduce our image swipe tool. A little button in the toolbar with a down pointing arrow allows me to choose which of the layers to swipe. Now, swiping essentially allows me to uncover the topmost layer to see what's underneath. So it's almost like pulling back some curtains. I can see that terrain, but it's also allowing me to see the overlying layer as well. We could, if necessary, at time, we could play with some of the transparency or blending options to allow you to work with multiple raster layers. Those options are certainly available as well. And if we could bring up our 3D again, obviously whatever layers you have loaded, in this case it's my ortho image, is also going to be displayed as a 3D model. So as you can see, my ortho image is now sitting on top of that original terrain model, and I'm now looking at a three-dimensional version of the terrain. Okay, Josie, would you like to process of generating contours?
Of course, David. Thanks. We're just going to load a new workspace here.
So Josie's going to be actually working with a slightly lower resolution workspace, lower resolution data set, just in the interest of speed and time.
Okay. So I'm going to be showing you how to create contours very quickly and easily with Global Mapper. I'm going to go to the analysis menu and choose the generate contours from terrain grid option. I want to create 10-meter contours. So I'm just going to update that, and I'm also going to use this contour bounds tab over here to limit the area. So I don't need to create contours for the whole area. I'm just going to draw a box around where my area of interest, and interested in this mountain here. Click OK, and let's see if there's anything else. I'm just going to leave this set as it is and click OK. Now you can see I have generated contours, and these are individual line features that have the contour line styling applied to them already. I'll just turn off the terrain grid so you can see the contours, and I'll show you the info tool that they also have elevation data for each line. You can also view this in the 3D viewer and manipulate the lines as if they're lines. So let's see.
And these are vector features, so yeah, they are exportable in any of the supported vector formats, including shapefile, DXF, etc. So I know a lot of people are using Global Mapper for this very specific purpose, the idea of generating contours, as Josie demonstrated. Very quick, very easy to configure your contours, and obviously very easy to export these as well. So very powerful function, very simple, but very powerful function in Global Mapper. I'm just looking at a couple of questions coming in here. There's one, I think there's a few actually, on the theme of generating custom shaders. We introduced very quickly some of those shading options. A lot of people are interested in looking at one here. Can you change the colors of the shader? I didn't go to the dialog box, but I guess I should now, given that there's some interest here. In the configuration dialog box under our shader options, right at the bottom, custom shaders. Now this is the same option that we could have accessed from the bottom item in the drop down list. If you recall, I showed you, it says create custom shader. Same end result. If I click the new button, this is the dialog box that lets you create your own custom shader pattern. You define a slope threshold value first of all, either meters or feet, and specify a color, and you can apply as many thresholds as necessary, generating your own custom shader. I would suggest checking the box blend colors, so you'll get that nice gradiated pattern as you saw in our example, where it doesn't have solid defined thresholds in terms of color differences, but rather blends them. So I'm not going to go any further with this dialog box, but this is where you would go to generate those custom shaders. Okay, Josie, once again, apologies, I'm going to have to remove your fine artwork here.
That's fine.
I'm going to turn on another layer. I want to talk about line of sight analysis / path profile. Now, the path profiling tool is a function that's been in Global Mapper for a long time. We've recently enhanced some of the functionality to include, for instance, profiling a point cloud. Those of you who sat on last month's webinar would have seen us do that. But I'm going to go through the very basic profiling process. There is a button in the toolbar right underneath my cursor that allows us to generate a 3D path profile. This tool simply allows you to generate an arbitrary line. I started from a selected location. You'll notice, just like the digitizer, I'm going to end this line with a single right click. It's only a one segment line, and it will automatically generate a cross-sectional perspective. So profiling is as simple as that. A couple of things to note about this profile view. The horizontal and vertical scales are not matched. People often think, wow, that's a very big mountain. No, not necessarily. You'll notice my vertical scales goes from 70 meters to 120, so there's about 50 meters of difference between the top and bottom, and yet my vertical scale, as you'll see, or my horizontal scale rather, goes all the way to over 2.5 kilometers. You can, through some of the display options, change that behavior For instance, you can match the elevation scale to the distance scale. I'm not going to do it right now, but you do have options to configure this display. You configure the colors, the grid line display, etc., etc., etc. And you can also make it a more realistic cross-sectional view by matching elevation scale to distance scale. So that's the very basic process of generating a cross-sectional elevation profile. Another thing I want to show you, again, just based on an arbitrary line, you may have noticed I turned on a small additional elevation layer. This is actually a layer that's actually below, in terms of height, below the surface layer. And what I'm going to do is generate a profile through that section. Again, simple single line segment. You'll notice now it's able to generate a profile of both. The dominant layer, the one that physically is sitting on top in my map, is the one that you'll see shaded. This green layer, the green outline represents the combination of the original surface and that subsurface layer. Perhaps this is a geological discontinuity or a bedding plane or something of that type. But you'll see that profile now representing that horizon as opposed to the original. You will, however, see the original horizon in a dashed form. So this shows you that you can create a profile across multiple views, across multiple terrain layers. One other thing I want to show you in regard to this profiling tool, and again, based on a simple arbitrary drawn line, I mention that because you can generate a profile, by the way, from a previously drawn line, which is probably more realistic in many cases, where the line actually exists. If that's the case, it's a right-click option. Go to the analysis menu when you right-click, and then it'll give you the ability to profile that pre-existing line. But again, in the interest of time here, I'm just going to draw this line fairly arbitrarily. Once again, a simple left click, right click. This time we're going to initiate a line of sight analysis. Now, as well as being a visual representation of a cross-sectional view of the terrain, the line of sight actually performs a visibility analysis based on this line. Line of sight gives you many options in terms of configuration. I'm going to keep this as simple as possible. I'm going to do a from elevation of 2 meters above the ground and a to elevation of 2 meters. In other words, maybe from the person's height to another person's height. Can I see my friend if he's standing on the hill opposite, if you like? I'll simply click OK on that, and you'll notice that I can. It looks like there's a little bit of an obstruction there. I probably should have had him stand right on the top of that peak. But this line gives you an indication of the visibility from one point to another along this straight line. Now, a line of sight can only be done obviously on a straight line. You can generate a profile on a multi-segment line, or perhaps a meandering line if you like. But obviously, in order to do this line of sight analysis, it needs to be a single line segment. Okay.
All right. How about information on viewshed analysis?
Let's see. I'll take my line off. Okay. Viewshed analysis. I'm going to turn off the offset example here. Now, Viewshed, we could do this very quickly and easily again, but I want to show you another kind of nice little trick here. Let's look at these three highland areas or upland areas in my terrain layer. What I'm going to do is I want to first find the highest point in each of these areas. Let's say that we want a vantage point, or we want maybe perhaps it's a broadcast location or a transmission tower with maximum coverage. We would assume that maximum coverage would be derived from having your transmission tower being at the highest point. So I don't know right now where the highest points are, so I'm going to very quickly draw a rough outline. I'm not worried about the configuration of the actual features I'm drawing, but I'm simply drawing three very rough outlines of these three hills, if you like. Now, the reason I do this is because I'm going to initiate an analysis process whereby I select all three, and I'm going to go to right-click. I'm going to go to my Attribute Style Functions submenu, and I'm going to calculate the elevation slope stats for these selected features. Truthfully, this is going to give me way more information than I'm interested in right now. What I specifically want to generate from this is a point indicating where the high spot is within each area. Now, confirming, it's asking me, would I like to generate those new point features, not only at the maximum, but also the minimum? Well, I'll say yes to this. It will also then generate a vast array of attributes for these features. Again, I'm not really overly concerned. The back of that procedure, as you'll see, are a series of points within each area. And in my case, I'm not that interested in the minimum elevation, so I want to remove, simply by using my delete key, those minimum elevation points as well as the original areas. They've served their purpose, so I'm just going to remove them. And there's the last one right there. And what I'm left with, and I think it's probably easier to see if I turn off the elevation layer, are 3 points. Those 3 points very specifically represent the high point within each area. Now, I'm going to use these 3 points to generate a series of view. A viewshed is essentially the same, or almost the same as our line of sight analysis function, except it applies in multiple directions. In order to do this, I'm going to first select the 3 points. Just want to drag my digitizer in its edit mode to select them all. You can see they're highlighted with a little red box. And then I want to choose the Viewshed tool from the toolbar. And I'm going to click at a random location on the map. Now it's going to ask me, because I have points, it's going to ask me if I want to create viewsheds for the points or for where I clicked. In this case, I want to generate those viewsheds from each point. Again, number of configuration options available to me. I'm not going to change any of these, again, in the interest of time, so I'm going to point out the radius, I've set it 3 kilometers. In other words, it's going to analyze from that point outwards, or from those points, I should say, outwards for a distance of 3 kilometers. I'm also going to analyze a full circle for each. In other words, 360 degrees is going to be analyzed. Everything else we'll just leave as it is. We'll click OK, and you'll see 3 separate status bars, if you like. The first one generating the first viewshed model, second one will bring the second one in, and the third one obviously will do the third one. So as you can see, we can generate multiple viewsheds concurrently. Now I have to tell you, the result of this is kind of messy. Lots of overlapping polygons, difficult to see what's going on here. But the bottom line is, everything you see yellow, by the way, I changed my color to yellow. The default would have been red. I'd forgotten I'd done that. But everything you see yellow can be seen from at least one of those points. Everything that's unshaded is invisible to all 3 points. We have a really nice tool from the analysis menu to make this a little easier to understand. If I go to analysis, count overlapping raster terrain, or you'll notice viewshed layers. This is a very interesting application for this tool, because what this allows you to do is create a more realistic visualization of what I just tried to describe. Note the elevation legend on the left side, going from blue to red as we had before, but in this case the range is only to 3. Given that I have viewshed models, everything that's red, in other words, all the red areas on the map, are visible from all 3 locations. Everything that's orange is visible from 2, green is visible from 1, and our blue right at the bottom is not visible at all. So this gives you a very interesting perspective on, perhaps you're putting in a lookout tower, fire tower, or again, broadcast transmission location. Very interesting way of visualizing that. Again, from the analysis menu, count the overlapping layers was the selection that I chose. Ready to talk about some volume calculation, Josie?
Yes, I am.
How are the questions? Any questions coming in?
Let's see.
I saw one on can you generate a terrain layer from contours? That's an interesting one. Actually, you can. I'm going to show you very creatively here. Let's assume we have a contour layer. Apologies, I should have left your contour layer in the workspace, Josie. From the analysis menu, if we go to the gridding function, as Josie did with those points, you will notice that it says, just 1 second, elevation grid contour options. This does not specify points. In other words, I could generate an elevation grid from any vector features, including contours. So if your contours have a z-value, which obviously most contours, if you import a pre-existing contour layer, they would have a z-value. You can go through this dialog box as well and generate an elevation legend from your contours. It might look a little bit like a step formation where the lines are, but you certainly could do that. So yes, the answer to that one is a yes.
Okay, just another question here about the viewshed you just created, David, about exporting and printing.
Exporting and printing. Well, printing certainly is an option. from the file menu, we have our standard print dialog box. I think we're probably overdue on doing a webinar on some of our printing options. We may do that some of these coming months. We'll talk a little bit more about the printing and exporting options. But certainly printing is an option. We could print what you see on the map. Exporting, these are vector features. We have generated these vector features, so absolutely, they can be exported in any of our supported vector formats. A PDF might be a good one to generate to give you a visualization of what you see on screen. So absolutely, definitely export options for our Viewshed model. I could turn off multiple layers, Josie, but instead I'm going to do the easy thing. I'm going to remove the workspace. I'm going to bring the same workspace back in again.
Okay, thanks, David. So I'm going to go through 3 different types of volume calculations that you can do with multiple terrain grids. So this is the same workspace we had before. David showed you the path profile through this separate elevation grid, and this is lower. You can tell by the colors that it's lower than the larger terrain here. So we're going to go through measure volume between surfaces, then we're going to calculate a pile volume, and then we're going to compare and combine surfaces. So I have the workspace open. Let's see. I'm going to measure the volume between surfaces. So I'm going to do analysis and measure volume between surfaces. Easy as that. I have the 2 here, just like in the overlay control center, you have the 2 options. And I'm going to click OK. And the resulting numbers here are values representing the difference between the 2. You can copy this to the clip. It has already been copied to the clipboard, so you can just paste it into any other application. And it's easy enough to recreate because we've got these files saved in the overlay control center, so it's easy enough to run again.
So that's a very simple one where you'd have 2 raster surface models. If you do have 2, perhaps you have a LiDAR derived canopy layer and a LiDAR derived ground layer. You can certainly use this to generate I don't know if it's a biomass calculation, I guess would be between the canopy and the ground level, but very simple process. Probably the easiest analysis tool in the application.
Okay, great. So I'm going to click OK just to close that. Now I'm going to look at the pile volume. So I'm going to draw an area feature, just let's see, around this hill here. Click OK. It's not important, and then I'm going to select it and right click with a digitizer and choose analysis, measurement, and pile volume. So this calculation measures the terrain relative to the edges of the area feature as it cuts across the terrain. So it's assuming that area feature is sitting right on the terrain. And again, we have our resulting values that can be copied and pasted. That they can be exported into a CSV file.
And there was, sorry, Josie, there was a recent improvement in this. I think it's worth mentioning. Up until I believe it was version 15, the determination of where to calculate the volume from was derived from the z-value of every vertex. In other words, Josie created an area with maybe a dozen or so vertices. Those were the elevation of those were used to create a temporary terrain surface from which to calculate. Similar in process to what Josie had done previously, which was calculate the volume between 2 surfaces. Obviously, in this case, Josie just drew an area, so the surface didn't exist. So it derived the elevation and ultimately generated a grid from the vertices. Now, recently we've improved that by essentially analyzing the elevation all the way around. In other words, the line itself, at specific points along that line, elevation is determined, so a more precise elevation grid is calculated in order to generate that calculation. Obviously, if it was a flat surface, it would not be an issue, but Josie generated an area that was obviously not in a flat plane. So.
Okay, great. So, and then the final option to compare combined surfaces is also in the analysis menu. Just gonna focus on our subsurface layer here, analysis and combine compare terrain layers. So this option is, what we're going to do is visualize the first step we did, measuring the volume between the surfaces, but there are a few options here under operation. As you can see, the list goes on. David, do you want to touch on any of these?
I keep continually learn from users of applications for this. I mean, we obviously can talk about this in a hypothetical sense, but there are some very, very interesting applications for this combined terrain. Combine is possibly a little misleading. What you're doing essentially is creating a new layer through an analysis of the z-values in an existing layer. So if you have two overlapping layers, such as Josie, the subsurface layer, if you like, you can generate a new model that has the average elevation between the two. This is excellent if you have two surface models, but you're not sure of which is more precise. You can average them. Might be a good idea just to get an average value. What's the maximum or minimum between the two? And this again is great if there's anomalies between two surface models and you want to make sure you keep the maximum of the values. Filtering options as well, as you'll see towards the bottom. Josie, I think the most common is the one that you're actually going to show us, which is the subtraction option. Two options for subtraction, by the way. Signed and unsigned basically means, do you want to respect the fact that it's a negative number, or just give me a value? So,
okay, we're just going to go with unsigned, I think.
Yep.
And we're going to select the two different layers and click OK. So as you can see, we have a new elevation layer that's been created because of this process. Oh. And that's the difference between the two.
Yeah, I think I want to stress here that this is not technically not an elevation layer itself, but it's actually a model of the difference.
Okay. Yeah.
So, Josie, I'm going to fire up the 3D window here real quick so we can actually see this. Let me zoom in a little closer. So again, not meaning to repeat myself here, but this model actually represents the difference between the surface model and that small subsurface area. In other words, where you see this blue area, there's very little difference between the two, 12 meters. Where you see the red area, that difference is 100 meters. So this is not actually the terrain, but the difference between those two models, just based on the operation or that analysis that Josie had selected.
Great. Do you want to go through cut and fill analysis?
Sure. How are we for time? We're looking good on time here. Let's we'll keep going until the last attendee leaves. How does that sound?
Sounds
okay. Kind of along the same theme, and certainly this is a function I'm about to show you that evolved out of some of the volume calculation operations within the application. We've streamlined this considerably. Those of you who have been on the Global Mapper bandwagon for some time may be familiar with GEM, the introduction of GEM, Global Energy Mapper, which is no longer available. We've integrated GEM into the standard version. What I'm about to show you is a function that was developed specifically for Global Energy Mapper that everyone now has access to, and it's extremely powerful. So what I'm going to do is load up a new workspace. I was trying to remember how I worded it, and that was pretty common sense, cut and fill. So again, the same layer I had before, the basic LiDAR derived surface model. You'll notice I have the imagery here as well, the ortho image. I'm actually going to turn that off temporarily. And we have this gray area. Now this gray area is an arbitrary area that perhaps represents a building site, or if you're in the oil and gas industry, maybe it's a well pad, or essentially a defined area that's you're going to use to flatten for whatever reason. Perhaps you're in the construction or engineering industry and you need to generate a flattened model. If I look at that area, that feature in my 3D window, you'll notice it's probably not the best choice for a facility, because it is a fairly hilly area, and I chose it purposely for this reason. So the challenge here is in determining the flattening that's required for me to have a viable construction site here, and this is our cut and fill analysis function that's going to allow us to do this. The process begins with the digitizer. I've obviously created this feature already. Perhaps this may be a file that your engineers provide. This is the area that we're interested in analyzing. I've selected it. I right-click, go straight to my advanced feature creation options, and create flattened site plan grid from selected areas. If you're using Global Mapper 14 or earlier, you'll not see this one in the standard version. With current versions, it is in the standard version. You no longer require Global Energy Mapper to access this tool. This is a very, very simple procedure in terms of how it's implemented. We can determine, if necessary, a specific flattening height. If we know for whatever reason that we need to flatten the terrain to a particular elevation, we simply type that value in here, and we can run the analysis. We can also flatten to specific heights within the area itself. In other words, if I had vertices around the edge of this, each of which had a z value, I can generate a calculated model and a modified terrain surface based on those actual values. And that's useful if your engineers have specified that we need the upper side to be perhaps half a meter higher than the lower side to allow runoff. You can be very specific on how this is engineered in this way. The middle option is perhaps the most powerful, in which Global Mapper is essentially going to be tasked with determining the optimal flattening height. In other words, I'm not an engineer, but I would assume that engineers would stipulate that in order to flatten an area, you want to move material from one side to another without the need to actually bring material in or without the need to remove material from the site. Essentially, it's like being on the beach, building a sandcastle, moving sand from one side to the other to create that flattened model. That's what we're going to do right now. We're going to have Global Mapper determine what that optimal height is by using this checkbox. One of the more recent modifications that was made to this tool is to allow around the edge. The initial application of this, we didn't actually factor in slopes, and we were quickly told that that's not very realistic. A vertical drop off at the end of my cut, or vertical cut at the upslope, isn't realistic. So you can now determine your slope angle based on what you see here. 0.5 for a 1 to 2 slope, 0.33 for a 1 to 3, etc. So you can determine your slope angle. You can also build in terraces or benches, if you like, around the edge. Now, the interesting thing about these options is they will also be factored into the volume calculation and will also, therefore, determine that break-even height that we're going to determine in just a second. So without any other configuration options, we'll just click OK. And it's going through the process of determining the optimal flattening height. Now, when this completes, there's going to be two results. The first result, similar to what Josie had shown us, is going to be a volumetric calculation. As you can see, it's going through checking various heights to determine the optimal height at which you can flatten. So again, we're going to get a volume calculation value, or a series of values, as you'll see. And once we've confirmed that that's what we want, it will also generate, as you'll see in a second, a modified terrain surface. So as you can see here, my cut volume, which is the first item, and the fill volume are similar. They're not exactly the same. We had a requirement to make these equal. They're not exactly the same, and that's simply because of the resolution of the data. As a byproduct, it's also given me within that area what my 2D cut area would be and what my 3D cut area would be, and similar my 2D fill and my 3D fill. And for the engineers, this is the break-even height. 106.443 meters. Obviously, depending on the resolution of your data, we're getting down to millimeter level or centimeter level of precision, I guess, here. The measurements have been copied to the clipboard for my convenience. If I wanted to paste those into a report or perhaps a proposal, I can do that. I'll simply click OK. And this is where we're going to see the second result of this procedure, which is a modified terrain surface. Now, my area is selected, so you're not actually seeing the area feature itself, so it allows us to see the modified terrain surface. One of the things you'll notice, it is a solid color. As we would expect, it's a solid color because it represents right that 106 point whatever the decimals were meter value right here, and you can see that's now a consistent elevation. I'll go ahead and deselect that. There's my area feature again, and we'll bring our 3D model up, and you'll see more clearly in the 3D what we've actually done here. You'll see the flattened surface, and you'll see the slopes that I asked for around the edge. So my 106 meter flattened area is optimized so that these areas that need to be cut from the upland area can be used to fill and create these slopes on the downslope area. Very, very powerful tool, obviously for visualization purposes, but also from an engineering point of view. Without actually having to go out into the field, you can generate very precise calculations and do a lot of preparation work before you actually sink a shovel into the ground. So, cut and fill analysis. Calculation.
Okay, great. Thanks, David. I'm now going to show you some options in the Watershed modeling analysis. I'm going to open this now, and I do want to unload the previous data, so I'm going to go yes, and here we are. If you've been to one of our training classes, you might recognize this. We have a point at a high elevation and a point at a low elevation. My first step, I'm going to select the higher point, and I'm going to have Global Mapper calculate the flow to a lower elevation. This is a good tool if you're looking at, oh, what if something spills here? Where's it going to go? Or any other options you have if you have a specific site and you want to analyze the effects from that site. So I'm going to go to the analysis menu and generate watershed. I'm going to choose the water drop analysis, trace flow from selected point, and I'm going to untick this one. We're going to do that next, and I'll click OK. Just takes a second here to process, and as you can see, a line is generated. We're flowing from this point down to the lower elevation. So this shows up on a separate layer that can be turned on and off and exported, whatever you need to do. The next step is we're going to look at selecting this point and figuring out what area drains to that location. So I'm going to go to the analysis menu and generate watershed again. This time I'm going to use the create watershed area showing drainage to selected point. I already have my point selected, so all I need to do is click OK. And as you can see, this pink area is the watershed that flows right to this point. We also have the streams that are created and where that water is coming from.
Excellent. And those of you in certain parts of the world, I'm not sure where everyone's logged in from today, but you may define this as a catchment area, or if you're, I think North Americans would refer to it as a watershed. There are other applications of the watershed analysis dialog box. You can generate watersheds for every drainage system. We had unchecked that, and Josie had unchecked that one before running her process. I think the two analysis that Josie showed us are perhaps the most useful. The water drop analysis, we've got a lot of questions about that, if it factors in things like soils or evaporation or anything of that type. No, that's not the intention of this tool. This is simply a terrain analysis tool. So what we're measuring, or what Josie was able to generate through that line with the arrows, was the potential for the terrain to support the flow of water, all other things being equal. Now, we consider that from a water perspective, but think of it as well as a tool that maybe will allow you to analyze outflow from a ruptured pipeline, perhaps. You know, you see there's a break in a pipeline. We were hearing this morning there's one up in somewhere in the Midwest. That kind of an analysis. Where do we need to put our booms across? And that's a very useful function for that. It may not be immediately apparent where the terrain flows to. That tool is very powerful for that application. So.
Great. David, do you think we have time for slope analysis?
I hope so. I have one question here, which is an interesting one, and we get this a lot. Hopefully I have a chance to show this as well. Somebody's asking, how do we find all areas over a certain elevation? And I'm going to quickly use this layer that you had, Josie. There's actually two ways of doing that. My elevation, as you can see, based on my legend, goes up to 122 meters. Let's take a situation where I want to find everything in this area that's over 100 meters. Again, a couple of ways do this pretty quickly. Analysis, generate contours. We've been here before today. One of the options here is to generate a contour only at a specified height. I'm going to enter 100 meters as my specified height here. I'm also going to go down to another checkbox that says generate area features. I'm going to check that one. So with a combination of those two checked, I'm only going to be looking at the 100 meter level, and I'm only going to be I'm going to be generating an area or a polygon or a series of polygons as opposed to just lines. I'll do that one very quickly and click OK. And as you can see now, I was able to delineate just areas that are over a certain elevation, in this case 100 meters. So that one was asked a few minutes ago. There's another way of doing that, by the way. If you go to the options for an elevation layer, there is an alter elevations tab in here. This is unique obviously to elevation layers. One of the options is to specify the range. Now this will actually constrain the raster elevation layer to whatever you specify in here. Again, I could put a minimum of 100 and it would limit the entire elevation data, not just generating those vector features, which is what I did with the contours, but it'll limit the actual elevation layer to what you specified. So two approaches to get to that same end result. Okay, finally, slope analysis. I'm going to go back to where we started. Let's unload all of this data and bring up the original work that we were working with. One of the visualizations I alluded to at the start of our presentation was to visualize terrain not based on actual elevation, but based on slope. and I'm going to choose that option right now. There are actually two variations on that theme. One is a slope direction shader, allows you to visualize south facing, east facing, north facing slopes, etc., or an angle visualization. Now again, I'm going to choose that option. When my map refreshes, what I'm seeing now is not elevation. You'll notice my legend on the left side is now indicating degrees. This is the slope angle. I'm very quickly able to tell from looking at this map where the flat areas are and where the steep areas are. If I, again, was planning an engineering process, I can tell very quickly where those relatively flat areas are that would suit my application. The question we often get is, how can I capture this information? How can I get this into a usable format? Because right now it's simply a raster visualization. Within the Overlay Control Center, one of the options we have for any layer, any raster layer I should say, is to create area features from equal values in that layer. Now, equal values can be different things depending on the layer. It could be color, it could be elevation, or it could be slope. Now, the fact that I have activated that slope shader, it knows that I want to capture slope. It allows me to set up a fuzziness value, basically a threshold for each area that's generated. I'm going to extend this slightly. I'm going to make a maximum match distance of 2. In other words, every cell is going to be matched with those that are 2 above and 2 below. You'll see the end result of that in just a second. And to speed up the process, I'm going to limit the analysis, similar to what Josie had done at the start, to a specific area. I'll just grab a section right in the middle here and we'll run the slope analysis in that area. Again, before I click OK to confirm, I'm generating a new layer. This is a vector layer, by the way. I should mention that as well. We're actually vectorizing a raster layer using this procedure. And again, my match distance is going to be 2 degrees. We'll click OK. And hopefully it will not take too long to generate. We will generate a new layer when my map refreshes, which it's still working. Watching my little wheel turn here. And hopefully will not take long. I'm going to see if there's any other questions we can answer.
I might just jump in with this question. How did we generate the high flow and low flow points in that watershed analysis? So they were just simply points that were created using the digitizer. It's just that we pick them strategically, but if you have a point feature that represents a sensitive site like a cemetery or something culturally significant, and you want to know what could be affecting that site, you would simply select it. So you could select any point, no matter what point style it has, and then run the analysis. Same if you have a potential source of flow, so that's our higher point. It could be an existing point, it could be something you create, and then you can simply select it and run the analysis.
Yeah, apologies. That instance of Global Mapper decided not to cooperate. So I'm going to very quickly do this again because it is worth showing this. This is the lower resolution data set. The higher resolution LiDAR data was taking a little too long to respond. So same procedure. Again, I visualize the data based on slope, right click, create area features. Again, my threshold I'm going to make 2 degrees, and hopefully when I define the bounds this time, it will respond a little quicker. And again, low resolution usually instant gratification. We'll click OK, and there we go. So I'll turn off the original elevation layer. What we're left with essentially are a set of polygons that, based on my elevation threshold requirements, allow me to filter or to decide, perhaps the best location for a construction site. Because these are vectors, they have attributes. I'm going to select one of these points, and you'll see, based on that 2 degree threshold I established, the min slope and max slope and the actual median slope are also noted here. So this is a fairly steep area. Because again, these are vectors, we could run a filter based on a query. We can essentially sort or build a query that allows us to find all the areas that are over a certain slope threshold, delete the remaining, and again you're left with those optimal areas as far as slopes are concerned. That procedure for vectorizing can also be done with elevation, by the way. I should mention that as well. But very, very powerful. Right click, generate area features, create area features from equal values. And that, I believe, is just about that.
Okay, well, hopefully our support team was able to answer the questions you asked today. If not, we'll follow up with you soon. On your screen, you'll see our support email address that you can use if you have any questions that come up in the future.
Yeah, and we have been recording this, so if you want to revisit, I know we went through some of the analysis processes quite quickly. If you need to revisit any of those, certainly the recording will be online within the next few days. Also, I should mention, believe the posting has been made for next month's webinar, about a month from now. We will be introducing version 16.1. Very powerful new functionality coming along with this interim release. I think the actual release is sometime within the next few weeks, but we will have a webinar in a month or so to introduce those new functions. Josie, thanks for your help today.
You're welcome, and thank you all for attending. We look forward to speaking with you again at next month's webinar.